All right, so here's our problem set. All right, so we're just going to learn basically adding and subtracting fractions using the same units, okay? And the units are right here. Let me zoom in on the first one for you, okay? This is a fraction kind of in word form, 3/5 and 1/5. And what does that look like? It looks like 3/5 and 1/5, okay? So here's the deal. When you've got 3/5 and 1/5, if you've got the same units, those are the units, fifths, all I need to do is subtract the numerators, right? If I have 3/5 and I take one of them away, I end up 2, right? Does that make sense? So if I have 3/5 and I take one of those fifths away, I have 2/5, right? So that's what it comes. 3/5 minus 1/5 is 2/5. Just like that. Same thing over here. 5/5 minus 3/5, right? So if I have 5 of something and I take 3 of them away, I just have 5/5, 2/5 left. That makes sense? Yeah, hopefully you're starting to get that a little bit. How about here? 3/2 minus 2/2. Well, if I have 3 of something and I subtract 2 of the same thing, and I just take 2 of them away, I end up with 1/2. Right? How about here? 6/4 minus 3/4. Talking about the same things, right? So 6 minus 3 is 3, and we're talking about fourths. Okay? How does that sound for you? Good? All right. Let's take a look here. Now we're going to take this and try to solve for this. 5/5 minus 3/5. 5/6 minus 3/6. All right? So I have 5. I'm taking 3 away. What do I end up with? 2, right? And we're talking about sixths. Good. All right, so when I'm doing subtraction here, all I have to do is subtract the numerators. As long as my denominators are the same, I'm just subtracting the numerators. Let's zoom in. 6/8 minus 4/8. So I have 6/8. I'm taking 4 of them away. That's 2/8, right? Let's check out this one. 3/10 minus 3/10. So I have 3 of these, and I take all of them away. How many tenths do I end up with? That's right, 0/10, or just 0, actually, right? 5/5 minus 4/5. So I have 5, I take 4 of them away. 1/5. E. 5/4, right? That's a fraction greater than 1, minus 4/4, which is exactly 1. So 5 minus 4 is 1. What am I talking about? Fourths. Good. And then 5/4 minus 3/4. Same denominator, so 5 minus 3 is 2. Denominator stays the same, 2/4. Okay? All right, so solve. Use a number bond to show how to convert the difference to a mixed number. Problem A has been completed for you. So a mixed number, we briefly touched on this the other day. A mixed number is when you have a whole number and a fraction together, okay? Like, how many pairs did you have? I had 1 1/8 of a pair, or I had 1 1/2. A lot of you kids say, I had 1 1/2, or you always, you use mixed numbers all the time, you just don't realize it, okay? So what they did here was do 12/8 minus 3/8. I ended up with 9/8. Do you notice how the 9 is greater than the 8 here? This means that this fraction is greater than 1. So what did I do? I took the 1 out of it, 8/8, which is equal to exactly 1, and there was 1/8 left over, so it's 1 1/8. Let's check out this one. Let's see if we can dissect this one. So let's do it. My denominators are the same, so I know I can subtract these no problem. 12 minus 5, right? That comes to 7, doesn't it? So I'm end up with 7/6, right? If I have 12 sixths and I take away 5 of them, 5 sixths, I get 7 sixths left over. So let's use a number bond here. When I'm talking about sixths, all right, if I take 6 out of there, 6 sixths, that's equal to 1, correct? Right, so how many sixths am I left over with? 1 sixth, right? Because, right, 6 and 1 is 7, right? Make sense? So this is 1 and 1 sixth. So this 6 sixths is equal to 1. And then this 1 sixth I just put right there. And this makes my mixed number, 1 and 1 sixth. Okay, let's try another one. All right, 9 fifths minus 3 fifths. All right, so fifths are the same, so I'm good to go. All right, it's gonna be fifths. So 9 minus 3 is 6. So I end up with 6 fifths. Now I wanna use a number bond, all right, to break this into a mixed number. All right, how many fifths are gonna make 1? Right, 5. 5 fifths will make 1. So if I take 5 from that, there's 1 left over, right? Doesn't 5 and 1 make 6? So that'd be 1 fifth. So this 5 fifths will be 1, and this 1 fifth, just go there, 1 and 1 fifth. I hope that's making some sense for you. Okay, let's check out this one. 14 eighths minus 3 eighths. So I'm talking about the same unit, eighths. So all I have to do is subtract the numerators. 14 minus 3 is 11. And what am I talking about? Eighths. So 11 eighths. Okay, so let's dissect this number bond. How many eighths will be the whole thing? Right, 8 eighths. So what plus 8 gives me 11? That's 3, right? Isn't 3 eighths left over there? Isn't 8 plus 3 equal 11? So that would be 11 eighths. So this would be equal to 1 and 3 eighths. See how that works? Yeah, 1 and 3 eighths. Way off on the side there. Good. And it's down to this one. 8 fourths minus 2 fourths. This will be equal to 6 fourths. Use a number bond. 4 fourths, right? Isn't that equal to 1? And I got 2 fourths left over. So this is equal to 1 and 2 fourths. Because that 4 fourths is equal to 1, and this 2 fourths just goes on the side. Okay? And then finally, 15 tenths minus 3 tenths. So 15 minus 3 is 12. 10, we're dealing with tenths, so that stays the same. You don't do 10 minus 10, that would be no-no. So, how many tenths make a whole? Well, 10 do. How many left over? 2 tenths. So that's 1 and 2 tenths. Just like that. Okay, 1 and 2 tenths. Good, huh? All right. Now, teachers, obviously, if you need to pause this and you talk about it, you can, all right? There's a lot of other ways you can figure out. There's another way here, there's a trick that you can figure out how to get this mixed number from this kind of fraction greater than 1. But I feel like doing it this way is helpful. All right, so on to the back. Now, in the back, it's all about writing the sum, all right, in unit form, okay? So, 2 fourths plus 1 fourth, okay? 2 plus 1 is 3. It's 3 fourths. Over here, how about 4 fifths plus 3 fifths? Wouldn't that be 7 fifths? Yeah. Down here. 2 eighths plus 5 eighths. I'm dealing with the same denominators, right? So, guess what? I can just add up the numerators. 2 plus 5 is 7. Dealing with 7 eighths. Okay, and then over here. 4 twelfths plus 5 twelfths. I'm dealing with twelfths, so that's twelfths. That's what my unit is. 4 plus 5 is 9. I get 9 twelfths. Okay, When the numerators are the same, you can just add or subtract whatever it's asking you to do, the numerators. So when the denominators are the same, you can just add or subtract those numerators, no problem. Okay, solve using a number bond here, okay? So solve, use a number bond to decompose the sum. Record your final answer as a mixed number. Problem A has been completed for you. We just did this in the back side, the other side with the subtraction, okay? So they're dealing with fifths, so 3 plus 4 is 7, so 7 fifths. And then they decomposed it. 5 fifths gives me 1. 2 fifths is what's left over, okay? 1 and 2 fifths. Here we go. Right? 4 plus 3 is 7, and we're dealing with fourths. Decompose this into 4 fourths and 3 fourths. Equals 1 and 3 fourths, right? How about this one? 6 ninths plus 6 ninths. Right? 6 plus 6 is 12 ninths, right? That's what I'm dealing with. So 9 ninths is 1. How many more to 12? 3 ninths, right? So this would be 1 and 3 ninths. How about 7 tenths plus 6 tenths? Dealing with tenths? Great. So 6 plus 7, 7 plus 6, I'm sorry, is 13 tenths, right? So this is 10 tenths is 1 and 3 tenths left over. So it'd equal to 1 and 3 tenths. Oops, I'm off the page. Let's check this one out. 5 sixths plus 7 sixths. So I'm dealing with the same denominator, so 5 plus 7, that's 12 sixths, right? Right. So, how many sixths make 1? 6 sixths, right? Good. How many are left over? Oh, wait a minute. 6 plus 6, 6, 6, right? Again. So that's equal to 1, that's equal to 1. Oh, so this is just 2. Isn't that neat? Yeah, that's right. And then 9 eighths plus 5 eighths. Isn't that 9 plus 5 equal to 14 eighths? So 8 goes in, well, what's 1 is 8 eighths. How many left over? 6 eighths, right? So this would be 1 and 6 eighths. Okay. You solve. Use a number line to model your answer. Okay, I can do that. So this is how this is done. This is an interesting way. So let's make a number line. And this needs to be split into fourths. Okay, but here I'm seeing this. 7 fourths. So let's draw a number line. And this one's going to be challenging. And I'll show you why. Okay? So 7 fourths is a fraction greater than 1. So we're going to make this equal to 0. Oh, I'm going to write that on the top, I'm sorry. It's going to be equal to 0. And this line is going to be equal to 2. Right? 2 wholes. Okay? And because the reason why is that I can see here that this fraction is greater than 1. So I need to show a number line that's going to go past 1. So what comes between 0 and 2? 1, right? So there's my 1 whole. Okay? So now what I need to do is partition each of my wholes into fourths. Okay, so I'm going to do this one first. Right? So I'll split this into fourths. One cut down the middle, and then cut 2 of them there. Right? Now I'll go from between 1 and 2. That's a whole, right? We're going to split that into fourths. Okay? See how that works? So now I zoom out. From 0 to 2, this is starting to look like a tape measure, isn't it? With all those lines in there like that. So you can see if I have that 0, 1, 2. Pretend that's the number line like that. And you see how I got my marks in here between all these numbers? That's what we're doing here, okay? So now I can see, all right, so these fourths. So all of these lines need to be fourths. So this is 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths. Isn't 4 fourths equal to 1, right? And then 5 fourths, 6 fourths, 7 fourths, and 8 fourths, right? Makes sense, right? When the numerator is double the denominator, that's equal to exactly 2. All right, so now I'm going to say this. Here's 7 fourths. So 7 fourths is right here. Now, if I subtract 5 fourths, right? This is, okay? I subtract 5, so it's going to be 1, 2, 3, 4, 5. Ends up right here, right? Does that make sense? So subtracting 5 fourths takes me all the way down to there. Make sense? Okay, that was a little bit, interesting. I taught this in 3rd grade a lot, but not last year so much. All right, now we'll do the same for this. 5 fourths plus 2 fourths. So I'm going to draw a number line. Put an arrow at the end, put an arrow at this end. Now I can see that 5 fourths is a fraction greater than 1. So I need to have a starting point at 0 and an ending point at 2. Now I'm going to split this into fourths again. So what whole number becomes between 0 and 2? 1. Okay? Now I need to partition each of these wholes into fourths. So I'm just going to partition 0 to 1 into fourths. 1 down the middle. Split that. There's fourths. 1, 2, 3, 4. Let's split this next hole between 1 and 2 into fourths. Down the middle, split those in half. Good. Now fourths. 0 fourths, 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, and 8 fourths. Okay, so I know how to do 5 fourths, which is right here, and I want to go up 2 fourths, plus 2 fourths, so it goes 1, 2. So it jumps 2 spaces right to there, 7 fourths. See how that works? All right, that was interesting and fun if you could see how it goes, but we'll be practicing this more, okay? So hopefully you learned today how to add and subtract fractions with the same kind of unit, same denominator. You just add or subtract the numerators, whatever they are, okay? All right, kids, nice job today. We'll see you tomorrow.